Let's go ahead and get everybody started here. I'm going to be using Packet Tracer. You guys had used the 5 pods of equipment, the routers, so I'm going to go ahead and use Packet Tracer up tonight. And you'll see the similarities. You know, much of it's the same here, what we're doing in Packet Tracer and then on the real equipment. So I'm bringing up as I would have connected up a console cable from my computer here to my router, and you guys did that in class. You had a console cable into your router for management. We call that out-of-band management. It's not through your regular data connection that you have on your Ethernet LAN. You plugged a cable into your switch, and your switch is connected to your router on gigabit port 00. And I'll do router A tonight. Those of you that are doing router A, it'll be identical to what I'm typing in. Now, the folks that are doing router B over here, you'll have slightly different addressing. So on all the interfaces, every router's got 2 interfaces that are going to be live tonight. One connects to your LAN side, that's your gigabit Ethernet port, and the other connection is between the routers, and that's through a serial connection, through a crossed over serial cable. Now this normally would be a cable, not the DTN, but not the DCEN, but the DTE cable would normally go to an external modem, and that would connect to your service provider. So think of that serial connection as a WAN connection, not a LAN connection, but a WAN connection, a point-to-point connection between 2 offices through your service provider. So you can think of router A and being in Fort Pierce, your Fort Pierce office, and router B being an office in Orlando. Okay, and you're going to get those 2 offices communicating tonight. All right. Okay. Now, of course, you're using the real equipment. I'm going to set up a terminal connection as I would in Packet Tracer by going to my terminal application and ensuring that the baud rate is 9600, the data bits, 8 bits, no parity, 1 stop bit, flow control, X on, X off, or none is fine. And then you see I've got a prompt for my router. That's how I would gain access to my router. Now, how would you gain access to your router? PuTTY. Yeah, so we got a freeware program called PuTTY. Go ahead and hit the Windows key and type in PuTTY. Fire up PuTTY. Okay, and what kind of connection type have we been using for that out-of-band management connection? Serial. Yep, we're going to go ahead and use serial. And remember, your COM line is likely not 1, but it's probably 4, I'm guessing, but it could be different on your computer. So if you need to, if you don't remember from the last time, if you sat at that computer, you can try 4, or you can right-click on the Windows Start button and bring up the Device Manager. It's about 1/4 of the way down from the top, and just open up your ports section. Expand the ports and ensure that your prolific USB to serial COM port's there, and identify the COM port number associated to it. Okay, that was right-click on the Start button and say Device Manager, choose that. Expand the ports, find your COM port number. Mine's 4. Yours may be something different. So just change that to COM 4 or whatever number you've got. Hit open, and you should get a line open. Hit the Enter key a few times, and you should get some text. Okay, take a note of the text that you're getting. If you're seeing, would you like to enter initial configuration dialog, your router's has a clear configuration, and you don't have to worry about a previous configuration on it. If your router comes up and looks something like mine here, maybe I'll go, let me see if I can resize this. It's really large, isn't it? Okay, I was just checking something, see if I could drop this down. I'm going to use this view because it's a little easier to look at. The white background with the black text there. If you see what I'm seeing, I'm being asked for a password on mine. That means somebody's configured this thing already. So what I'd like you to do is, if you have a password, it should be either Cisco, C-I-S-C-O, lowercase, or class. Okay? Now, does anybody have a router name that's other than router, or raise your hand if you were asked if you want to get into initial configuration dialog. Boom, 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 boom. Andrew, no? Dane, you had a password? Dane? Okay, and did they work out? You got in? Okay, perfect. Okay, so Dane and Andrew, you guys need to follow my steps. We're going to just do a race startup config and a reload on our routers so that we wipe out the configuration on them. If you buy a used router, or you get a router and you want to just start from scratch, if you're able to log in and get to privilege mode, then you can wipe it out by giving yourself an erase startup-config. I'm going to use the tab key to auto-complete it. Make sure you confirm by hitting enter. Okay, and it should say erase of NVRAM complete. Now when you say reload, it may come up and ask you, the configuration's been modified, do you wish to save? Make sure you say no to that question. Okay, say no to that question. So I'm going to say reload and proceed with the reload. I'm going to hit enter to confirm that. And what we did is we deleted the startup configuration and we rebooted the router so that it should come up and ask us if we want to get into initial configuration dialog. Okay, and we'll be at the point where everybody else is on their routers. Now, this is Packet Tracer, so it reloads really quick. Dane and Andrew, it's going to take your guys' routers a little bit, but just kind of keep an eye on them while we lecture. And in a couple minutes, you'll be back. Oops. Oh, I said no. Would you like to enter basic man? Nope. Okay, I just broke out of that sequence there. Control-C will break the initial setup dialog if you get into it. Okay, let's get into Module 10. And we're going to move fairly quickly through this because a lot of it's going to seem similar. You know, we did a good bit of it last week and in the weeks prior. So we're going to walk through configuring a router tonight, which we've done. And we're going to pull back some of the stuff we had done when we did an initial configuration on a switch. So some of these commands should look very, you know, you've seen them before. You did when you configured a switch. And, you know, what are some of the basic configuration steps? Well, in a device, a network device, typically you'll give it a name. Okay, so there's our host name command, the top one. Then it's all about, you know, securing access to that device. So the first thing you'll see is the enable secret command. Remember what that does? Can anybody explain to me what the purpose of the enable secret password is?
Makes password required when going to the privileged.
Yep, that's exactly right. Yeah, so when you're moving from user mode, which is a limited diagnostic mode, you can't really do anything to hurt the device there. Moving from that to the # privilege exec mode, where you're an administrator, this will prompt you for that password that you supply there. So that password protects the ability to get into administrative mode. Then you'll see the line console and the line VTY. Whenever you see line, think of that as a means of accessing the device. Okay? And out of the two, your console or virtual teletype lines, which one is considered out of band? An out of band line. Austin, you got a 50-50 shot, so give it a go. Which one do you think's out of band? Nope. Console. Okay, your console's considered what we call out of band. And the reason for that is because it's not using your normal network connection. It's out of the normal way we send traffic through our Ethernet line, through our LAN. Out of band means using some other separate physical means to connect. Okay, so with routers, you have a console cable. That console cable can be used if you're close enough and you can get in there and use a console cable to connect into your device to configure it. Routers, unlike switches, they may have an auxiliary port. The auxiliary port can be connected to a regular old dial-up analog modem. So you can actually, if you have a site in Dallas, Texas, and the router gets messed up and you can't access it, remotely through the internet, guess what you could do? Well, if you had a little modem connected to it, you could dial into the modem, with a regular analog modem, and access the router through the auxiliary port, remotely, without having to jump a plane or, to Texas, right? Or walk somebody through it over the phone if you got somebody in Texas to do it. Okay, so your virtual teletype or your telnet or SSH connections go right through your network connection. They can go on your LAN, on the WAN, but they're used for what we call in-band management. It goes right through your regular network connection. The service password encryption command, and then on both these methods of access, you can password protect it. Later in the class, this isn't the real preferred method of doing it. The preferred method is to set up user accounts for everybody. And when they go in to administer devices, they're prompted for a username and a password. But for now, up until we get later in the course, we'll then create user accounts and we'll log in using authentication that way. When you do set up these passwords, unlike the enable secret password, which gets encrypted, these ones are stored in clear text. So the service password encryption command will encrypt those, okay? Now it is weak encryption, but at least it'll prevent someone from looking over your shoulder and identifying the passwords. You got a little banner message. We did these commands on the switches before. Did wanted to say Austin. Andrew and Dane, did your routers reboot? Perfect. Okay, so you're at a router prompt with us? Awesome. Okay, so get me going. Is everybody, raise your hand if you're not at a router prompt? You all good? You're not? Oh, say no to that. Yeah, say no to the initial configuration dialog. And if it says terminate auto install, say yes to that. Okay, and then your router's going to have to jump around just for a minute, and it will get there. So I'm going to give you a second while that's coming around. So we're going to go ahead and do those commands, set it up with a basic configuration, and then you see at the end here, I probably won't have you issue this command just because I've been doing so many password recoveries. I'm doing one every week or more. This week I've already done two. So people are using passwords that I don't know, and I kind of make sure when we're in class and you're on the real equipment, use Cisco in class. Okay, it takes me about 10 minutes to do a password recovery on a device, and I'm not blaming anybody. I have no idea who's doing it, so I'm not. It's an annoyance. It's an annoyance that I keep getting bothered by. So I'm going to have you skip doing this command, but in the real world, once you've configured things and you want to save it to non-volatile RAM so that if your device power cycles, that configuration is, stored, you would do a copy running config, startup config to save what we've done that's being stored in RAM to non-volatile RAM. Unless you do that, everything's being stored in RAM in what's called the running or active configuration. You need to back it up to non-volatile RAM to ensure that it's retained on a power cycle. Okay, so how we doing, Carson? Well, good. Okay, so let's go ahead and elevate access. We'll give ourselves an enable and a configure terminal and get us up to a global configuration mode prompt. And let's go ahead and issue the hostname command. Now remember, you can abbreviate all these commands. So when I said enable, I just typed ENA. When I said configure terminal, I just typed conft. And remember, your other tool to help you speed up typing is the tab key, which auto-completes stuff for you. So I'm going to play the role of router A tonight. So go ahead. If you're router A, simply give yourself an RA for a name, or router A. If you're router B, give yourself a router B or an RB for your name. Oh, for your name? Oh, yeah, you're A. You're going to be A tonight. Carson, you're B. Yep. And let's go ahead and set up our passwords first. So let's go ahead and set up the enable secret password. So give me an enable, secret, and the password that you want to use. And so in class, let's make use of Cisco, C-I-S-C-O, lowercase C-I-S-C-O. Okay. If you have any questions as you're moving along, just raise your hand and give me a holler. It's best to resolve any problems right away before going too far and getting it. Okay, and let's then, so we'll first do the password protection that's necessary. So let's go in and also get into our line console 0. That's our console port. So give me a line console 0. And let's set the password on it. So give me a password space class. And all the passwords will be in lowercase, C-L-A-S-S. And you need the keyword login for it to take effect. So when somebody's logging in through the console port, it's going to ask them or prompt them for a password. And they'll need to provide class for that. Now, here's a couple things that we may not have talked about. There are some nice things you can do on your console to help things out a little bit, make things easier. This is not something you're going to get tested on, but if you say logging synchronous at the console line, you may be in there configuring things, and when you make changes, sometimes that will bring a service up, or it'll bring an interface up, or bring one down, and the router will send messaging to the console. And so as you're typing, all of a sudden you may be right in the middle of a command, and it interjects a bunch of output to your screen, your console screen. And what this does is allow, once it does interrupt you, it brings you to a fresh line with the text that you've typed so far. So it's just kind of a nice thing. It helps keep things organized as you're going. Okay, and another thing that you may encounter is you can do a speed question mark. If you, I had somebody in class that works for the school district, and they were saying how last week they were dropping configurations into their switches. They just moved, I think St. Lucie County just moved over out of the Orange Blossom Mall. They did a while ago. They built a new school district office in St. Lucie West, right off of 95. And did you see that building go up there, right on St. Lucie West Boulevard and 95 there? Well, anyways, they were configuring, a bunch of switches, and they had their configs that they wanted to drop in there. But when they were dropping them in, they were pretty lengthy configurations, and they would choke up. So as they were just taking the text and copying them from Notepad into the switches, it wasn't keeping up. It was pasting too much text for the baud rate of 9,600 bits per second. So if you want, in that scenario, what he said he did is, he just chunked up the data and just took small amounts of text at a time and plopped it in. That works, that's fine. But another way to get around that is you can change that 9,600 bit rate on your serial line. You can up it, okay? So you have to remember, if you up the speed on the physical console port, what do you have to do on your computer? You got to up your connection speed in PuTTY. That's right. You got to go in your PuTTY settings, because you'll lose connection to your router when you do this. You got to go into PuTTY and match the speed setting in PuTTY. Okay? So that's a way to help that if you're dropping large configurations into your devices. Okay, so enough of the console port. Let's do a line VTY 0 space 4. The VTY stands for virtual teletype, and it's your terminal access through the network, okay? In-band management, remote management of devices using your regular Ethernet data line. And we can use connections like Telnet or SSH to do that. And do you remember the difference between Telnet and SSH? What's the difference? The encryption. Yep. So Telnet sends everything clear text, whereas SSH will form an encrypted session first, and it's much like the difference between HTTP and HTTPS. So now your curriculum will say line VTY 04. The reason they put 04 is they're allowing for 5 concurrent management connections. Okay, and most of the Cisco appliances support up to 16. So if you want to max it out and allow up to 16 concurrent management sessions remote, you'd say line VTY 015. Okay, but saying 4 is fine. Give me again the same 2 lines with the password class and the login command. Of course, you can use different passwords for your console port and your Telnet lines. Another command they show you in the slides is the transport command. Give me a transport input ? And in Packet Tracer, I just have a couple options, but you probably have more options on your real routers. And this is the 2 options I have here, SSH and Telnet for the application layer protocols. Remember, when you fire up PuTTY, when you fire up PuTTY, you've got a few options to choose from, and you can go with the more secure SSH connections, which it defaults to, or you can choose clear text Telnet connection types. Okay, so go ahead and say transport input all for tonight. Later in the class, we'll get a little bit more on best practices for security. Best practice for security would be to say transport input SSH. That will restrict you to only being able to use encrypted conversations. Now, that will make us have to do some extra configurations, and we'll do that in a later module. So I'm just going to hold on that for now. But only thing you missed there, Austin, was this. And if you want to do the transport input all command. So just this bit. Okay, and give me a, that's it. That's all we need for the Telnet and console connections. Let's drop back a mode to global configuration mode. When you do log in, if you want to provide a message like a warning, or a login banner, let's go ahead and say banner, message of the day, so that's MOTD, and then your delimiter character, which can be any character you want as long as it doesn't appear in the message itself. Because if it appears in the message itself, that will stop the message and you'll only be displaying part of it. So I'm going to go ahead and use the pound sign. If you hit enter, you can do a multi-line message. So it can be 50 lines long if you want it to. Or you can just put the command all on one line. So I'm just going to keep it short. I'm going to say unauthorized access. Now, actually, I'm going to do this just so that you see what happens. Oops. If I can spell prohibited. Here. Okay, so watch what happens if I include the delimiter character inside the message contents. And what you'll see when I log out and log back in again is the word prohibited won't be displayed. Okay, so I'm just going to do this. You don't have to do this, but let me quick jump out. You stay where you're at. Okay, watch when I log back in again. See how it stops at the first indication of that delimiter character. It did not include anything after the delimiter character. So make sure the message doesn't include the delimiter. Okay, I'm getting back in here to where you guys are. Okay, and give me how can I view the current configuration that we've entered? Show running -config. So give me now what would happen if I type show run or show running config right now? Yes, if I do the show command, any show commands right now, they will come back as an invalid command because I'm in the wrong mode. So you cannot issue any show commands in a configuration mode unless you put a do in front of it, because they're typically done in user mode or privilege mode at the pound sign. So give me a do show run. Okay, and here you see our host name command. Setting our host name, here's our enable secret, and our password's been encrypted. Okay, and this is the type of algorithm that was used, indicates the type of encryption algorithm. Down below, if you hit the space bar, just keep going right down to the bottom, get over those interfaces, and you'll see your banner message. See how it cut off, and here's my delimiter character left off the word prohibited there. There's our console line in our virtual teletype lines. And notice how the password's being displayed in clear text. So to clear that up and make sure that someone looking over our shoulder doesn't identify the password, give me a service password -encryption. Service password -encryption. Okay, and then just take note, I'm doing a do show run again and space barring to the bottom. You know, someone looking over your shoulder may not identify that this is class, you know, but if they are sneaky and take a picture of it on their phone and they just jump on the internet and type in type 7 reverser, Google it, you'll find one on packetlife.net. In their toolbox, they got a type 7 reverser, and you just paste that in there and reverse it, and there it is. Okay, so very weak encryption, right? Just prevent someone from shoulder surfing. So if you ever are asking a friend, or you know, I've had students send me configurations, you know, from their workplace and ask for assistance on something. they've oftentimes sent their configuration file to me without deleting the password in the configuration. Physically, when you send it, you should physically delete the password line from the text file. You know, so don't assume that encryption. You know, what they did is they gave me the administrative password to their workplace network. Okay, so I'm a nice guy and wouldn't take advantage of that, but you know, someone else might. Okay. Alrighty. Oh, and don't do this on your routers, but I'm going to go ahead and do this. Tonight, when you're done, I'll be able to just walk in and unplug the power, and everything we've done tonight will disappear from your routers. But I'm going to go ahead and type exit here. You don't do this. I'm going to do, just so you see it, the copy run start command. And this command will then allow you to reboot your router and have everything that we've done so far to, you know, previous to this will be in your non-volatile RAM, and it'll load when you reboot the device. So skip that step, but if you remember to do this in the real world, remember to do that step, because otherwise when the device power cycles, you'll lose all of your configuration that you've done since the last time you did a copy run start. Now, if you do, if you would, on your router, please give me a do show start. Okay? And what do you get, Will? Startup config is not present. Okay? So until you back that thing up, you have no startup configuration file, and the next time when I go in and unplug the routers, plug them back in again, they're going to come up to the initial configuration dialog. Everything that you do is being stored in RAM. It's not until you copy it to non-volatile RAM will it be retained. Okay? And the one thing to remember is everything you're doing on the router command line or switch command prompts or on your firewalls, they're all immediate effects. They affect the device immediately. As soon as you type it in on the command line, it's an immediate effect. You don't have to reload to have these things take effect. Okay? So I remember I had somebody in my class, you know, this must have been probably over 10 years ago, but he was an IT manager for a call center. And he hired on a new guy to take the night shift, and he started getting calls. And this is back, it must have been probably 15 years ago, because there were still pagers. Remember pagers? Or maybe some of you are too young to even remember pagers. Okay, but we do. I do, anyways. And he would get paged, you know, from work, and that the network went down. And so he's like, man, in like 2 weeks he got paged, you know, two or three times. And he's like, what in the heck? But by the time he got in, the network was back up again, and internet was back up again. And it took him a couple of weeks to figure out. His junior tech he hired on was studying for his CCNA certification. And he was playing around on the router and testing some of the commands. It was either the router or the firewall, I can't remember. At any rate, he was dropping the network and then bringing it back up. At least he was smart enough to reverse the commands as he was going back through. He'd reverse them and bring it back up again. But it's like, man, don't do that on a production device, you know, because it affects. You play with the router, you're potentially dropping the business's connection to the internet, okay? And that can affect the bottom line. So make sure all testing goes down on a non-production device. Okay, and what you didn't do on the switch, if you remember when we were configuring the switches, is we did set up an interface on our Ethernet switch. So in the closet, you know, the switches look similar to this. You have a bunch of ports, and the the main goal of a switch? What's the main purpose, if you had to describe this to a non-IT person? What's the purpose of an Ethernet switch? To switch between passive data. That's kind of what it's doing.
To route your local internet data.
Not really routing internet data. You're kind of tap dancing around. Make connections.
Allow the computers to be able to communicate with each other
Yeah.
on the inside.
Yeah, there you go. Look at the difference between a switch and a router. And think of the ones in the closet. They look very similar to this. The switch's job, the reason it has so many ports on it is because you're aggregating and tying in all the LAN devices. You're getting a bunch of devices connected up so they can communicate on the LAN, right? And they can see one another on the LAN. And then you're going to connect in your switches together, and then at some point they'll connect to a router that's going to probably connect you to the wide area network, or it's going to segment and offload maybe different portions of your campus LAN. But typically it's what's going to change media types and protocols to what your service provider is using. Okay, so you don't see as many interfaces on a router, and that's because a router's job is not the same as a switch's job. A router's job is to connect different networks together, not to connect, a bunch of devices together. Okay? So which one of these two devices would you say operates at layer 2 of the OSI model? The switch does, Andrew said. Okay? And that's a good answer. Why, Andrew, would you say the switch? Can you describe why the switch is a layer 2 device? It's linking everything together. It's at the physical and data link layers. Why isn't it going to the network layer, or layer 3 of the OSI model? Because then it'd be a router, and it would be switching data or routing data on a different kind of address. Yeah, so at layer 3, when we say something's a layer 3 device, that means they're using a layer 3 address or a logical addressing scheme, which is called, in our case, we're using the internet protocol to communicate. Okay, and IP addresses are used to route traffic between networks. What kind of addressing is used at layer 2? MAC addressing, the media access control or physical hardware addressing that's not put in through software or through operating system configuration. It's done by who? Who puts in the MAC addresses? The manufacturer does. Yep. So Dell, HP, Cisco, Hewlett-Packard, everybody, those manufacturers are getting the vendor codes, and then they program in the serial numbers on the unique devices to make sure everybody gets a unique MAC address. So remember, switches, layer 2 switches. When someone just says a switch, assume it's layer 2. But there is this thing called the layer 3 switch, or a multi-layer switch. Those are actually switches with the added function of being routers. Okay, and they'll operate at layers 2 and 3. You won't see any difference on the outside, but it's the firmware inside that's the difference. Okay. All right, so remember, switching, layer 2 switching, everything's connecting up in the LAN. We're forwarding traffic based on MAC addresses to hosts on the same LAN. When we go to the router, it's connecting different networks, and it's going to be forwarding traffic on those logical addresses. So what I'm getting at here is we did program an interface on this switch and gave it a layer 3 address, an IP address on the switches before, but that was not a physical port. These physical ports only get identified by MAC address only, and what we did is we created a switch virtual interface, or an SVI, that was a virtual interface that identified the switch as a whole to the network so that we could telnet or SSH to it. And that was interface VLAN 1 was the name of that switch virtual interface. And then we assigned an IP address to the switch. Now, what's different about a router is that each operational physical interface will need to be programmed with those layer 3 addresses. Okay, so that's a big difference between a switch and a router here in its configuration. So let's go ahead and set up our router with the addressing. Okay, we're at a point where we need to configure those interfaces. So the console password is the first one that pops up. If you got timed out and you don't even see a prompt until you router prompt until you provide that console password. When you type enable to elevate access to privilege mode, then you're being asked for that enable secret password. Okay, I'm doing a configure terminal to get to global configuration mode on my router where we're going to start making changes, and we're in good shape here. So let me see if my router prompt. Okay, excellent. Oh, here we go. Now we're cooking. Okay, so go ahead and give me an interface, gigabit 00, interface gigabit 00 from global configuration mode. Notice our prompt changes to a config-if, referencing the fact that we're in interface mode. So the commands that we issue only affect that one interface. They won't affect any other interfaces on the router. It's just our connection to the LAN, to your LAN switch. It's your Ethernet connection. So let's go ahead and set our Ethernet properties. If you're router A, you'll type exactly what I'm typing at an IP address of 192.168.1.1 with 255.255.255.0, okay? Now, if you're router B, you're going to use the IP address command, but your IP address is going to be different. So if you're router B, replace the 192.168.1.1 with a 10.1.0.1 and replace the 255.255.255 with a 255.255.0.0. Okay? So you should, if you're router B, give me a 10.1.0.1 with a 255.255.0.0. All right, and hit enter. Make sure you raise your hand if you got a problem as we're going. Then give me an IPv6 address. So what we're doing is assigning a logical address to these interfaces, these physical interfaces. And a router needs really two things to happen on it to make it work, to function. One is you got to program the interfaces, and the second thing is you have to set up the routing table, which we'll get to in a minute. Now, for each routed protocol, when we talk about the Internet protocol, there's two different versions that we're speaking of. Version 4, anytime you say IP, you're really referencing IP version 4, the older protocol. And IP version 6 is the new revision of the Internet protocol. We'll talk about the big differences there, but just suffice it to say that we're using decimal numbers up top for IP version 4, dotted decimal format. We use hexadecimal numbers for IP version 6. So the bottom two numbers that you see for IP version 6, the first number, 2001:1 or 2003:1, those are routable on the networks and through the IP version 6 Internet, through the Internet, your service provider, and through the Internet. The IP version 4, the address below that, so the first one's IP version 4, the bottom two addresses are IP version 6. In IP version 6, the interfaces will have multiple IPv6 addresses, not just one. Okay, and the first one that I described, the 2001 : whatever, that's called a routable address, and the name they give that is a global unicast address. Okay, that's what it's GUA, global unicast address. The IP version 6 address right below it is what we call a link local address, and they have different purposes. The link local address is used by application layer protocols and services, network services, to communicate to hosts on the same network. So its scope is local in scope, not global in scope, meaning routable through different networks. So and we'll see how these different addresses come up. So give me an IPv6 address 2001 : 1 if you're A, 2003 : 1 if you're router B. So give me a 2003 : 1 if you're B. And you have to include the network prefix. So like when we type it in IP version 4, we have to type it in dotted decimal format. With the IP version 6, because of the formatting, we're using a different number system. We're typing it in as in a bit count format. It means we've got 64 bits in our mask that are ones. That's our network portion, our prefix. Give me an IPv6 address FE80 : 1 if you're router A, FE80 : 2 if you're router B. And then instead of providing the prefix, tag it link-local. Okay, so the only difference if you're router B, it's going to be FE80 : 2 instead of 1. Okay. You can use the description command if you say description or DESC for description. You can give an English-like description of commentary on what this interface is. So mine is the connection to LAN local area network A. If you're router B, it's your connection to local area network B. It's just a commentary. It has no effect on the operation of the interface. But the next command does. Give me a no shutdown. So to turn an interface off, you say shutdown. To turn it on, you say no shutdown. So to do the opposite of something, like if you type something in incorrectly and you want to undo it, just use the up arrow and bring the command up again. Go to the beginning of the line and type in what? No. Okay, and that will undo what you had done. Okay, that'll remove it. Okay, let's go to the serial side. Give me an interface serial 020. There may be somebody in the closet. I think I just remembered one of the Ethernet ports was not connected to a switch. I'll take care of that when we take a break here in a few minutes. But otherwise, you should have seen your line protocol, your interface and line protocol come up. There might be somebody in the closet missing a cable, and I'll take care of that on break. So one of you may not have seen that come up. Okay, let's just walk through and set up the addressing on the serial side, and then we'll take a break here. Give me an IP address of 200.5.5, and that's the same on routers A and B. It starts with 200.5.5 on both routers because this is a point-to-point connection. When you have hosts on the same physical segment, network segment, they have to share the same network number. Okay, and in this case, the first 24 binary ones represent the network portion. That's the first 3 octets or first 3 bytes, or in dotted decimal format. So give me a .1 if you're router A, and the only difference if you're router B, it's going to be .100. It's this one right here, .100. And they both are using the same subnet mask. So you have to give a subnet mask of 255.255.255.0. Okay? Let's go ahead and set the IPv6 addresses up. We got 2 of them we're going to go ahead and do. IPv6 address. Give me 2002. They're both going to start 2002 double colon. Yep. Okay, so if you have an overlapping address, that means you did a similar network number on the previous one. Or you didn't change interfaces. Let's see. Oh yeah, you were starting to do other addresses here. Okay, you needed to do a 10.1. That was the right address, but you have the wrong setup. Okay, so take a break. We'll come back. I'll get Carson back. Take a quick break. We'll finish up this. Everybody back. So on your serial side, I just took over Tyler's router. He had to run to work. So Dion, I didn't want to leave him hanging there and have half of the network not done. So I disconnected from the college network. I hooked up to router B. Okay, so I'm doing a router in the closet. So if you were A and you were copying me on the board, you can't do that anymore. Now it's the B folks that'll be identical to me. I'm doing router B. Okay, and so I just set up the addressing for router B to match, and so Dion has a partner there, network, and I'm in the serial 020, and I forget where we left off in our commands setting addressing on serial 020. But we set the IPv4 address, and then we're starting to set the IPv6 addresses. And now remember, if your router A, your global unicast address is going to be 2002:1, and your link local is going to be FE80:1. So make sure to change these numbers. If your router A, give yourself an IPv6 address 2002:1 instead of 100. That should just be a 1. And then the line below, IPv6 address FE80:1. Just make that 2 a 1 for router A, folks. If you're router B, it's going to look identical to what's on the board. Okay? So what we're doing is we're setting up these interfaces. So you can look to the bottom 2 addresses here. They're the ones that we're using right now for IPv6. Okay. One thing to note, if you put in the wrong IPv4 address and you want to change it on an interface, you can just reissue the command again with the right address and mask, and it will overwrite the old one because it can only take one IPv4 address. But for IPv6, if you put in, you mistakenly type something improper, if you type the new command with the right address and mask, it will not overwrite the old one. It will go in addition to. And that can cause problems because a single interface can take multiple IPv6 addresses, unlike IP version 4. So the moral of the story, if you type something wrong in IPv6, you better do what? You better put no in front of it and reissue it again to remove it. You can't just overwrite it.
Did I do it right?
You're in global config mode, yeah, but you got to be in interface mode to type those. So if you got timed out on your router when we're on break, get back in, do an enable, provide the passwords, give yourself a configure terminal, config T, give yourself an interface, serial 0/2/0, and then you can put in those 3 lines at the bottom there. Remembering that if you're A, use these addresses, right here. If you're router A, use these addressing addresses in the 3 lines below. If you're router B, you're using these 3 addresses or what's displayed on the board. Andrew? Yeah, you don't do the /64 on the link local address. You tag it link local. Instead of putting the network prefix, you tag it link-local. So if I were to type something wrong, it'll let you know. It's got a syntax checker. It'll say invalid command, you know. So you'll know. I mean, unless you type it the wrong number, it'll take wrong numbers, and you know, if you put in 1 instead of 100, you know, it'll take it, won't complain, but it could be wrong. Well, it's just the way the protocol goes. So you will have different IPv6 addresses will have different meaning for the interface or different scope. It'll take unicast addressing that's routable. We call those global unicast addresses. There'll be addresses that are only on a local network scope. Those are link local addresses. There'll be multicast addresses that will be assigned for group messaging. And there's other ones as well.
And then for A, you said what would we change? Like
Did you do a?
Yeah.
Did you get your IPv4 address in?
Like the regular IP address?
Yeah.
Yeah, I got that in.
200.5.5.1.
Yeah, that was all the way.
Okay, you got that in before. Okay, perfect. Your IPv6 address is going to be 2002:1. Okay, /64. So it's right here. You're doing router A. Your addressing's right here. Okay. Austin?
In the 2001 164 is whenever we're setting up the gigabit Ethernet.
That's the other interface. Yeah.
That we already set up. Okay.
And that we already set up. Yeah. Okay, and you can give a description if you want. This doesn't affect the operation of the interface, but go ahead and give your description. Say connection to network. I'm going to say it's description to network A over there because I'm connected to my buddy Dion, who's network A. If you're B, you're connecting to A. If you're A, you're got a connection off to your buddy on network B. And then how do we turn it on? No shutdown. Give me a no shutdown. Now, once both devices have been properly configured, then the interface will come up. Okay, so like you'll notice the Ethernet port came right up as soon as you got it going. That's because the switch you were plugged into is already up going. Okay, on the serial side, it takes both you and your buddy to open up that port and configure it before you'll get an up state. Okay, so when it says interface change to state up, that's physical layer. When it says line protocol change to state up, that's the data link layer. Okay, then you're addressing at layer 3. And how do you test, or how do you review and see quickly if your interfaces have been configured correctly? We're going to say do show IP interface brief. Give me a do show IP interface brief. Okay, and what you should see, you ought to see your gigabit Ethernet side, 00, with, if you're A, it ought to say 192.168.1.1. If you're B, it's 10.1.0.1. And here's an important thing. The status, physical status, should be up, and the line protocol should be up. If you've got administratively down and down, that means you failed to issue a no shutdown. If you've got a down and down, that means you've got a bad cable or something. A physical layer being down is a bad cable or a no cable, that sort of thing. If you've got a down and up state, that would be a layer 2 issue. Usually it's an encapsulation format or bad modem, maybe attached to a serial side. Those could be indicators of that kind of problem. And on your serial side, you should see up and up as well. And if your router B, you got exactly what I've got here. If your router A, the only difference is you should have 200.5.5.1. Okay, anybody see anything different on their router? Okay, perfect. All right, then guess how we see the IPv6 configuration?
Do you show IPv6 interface brief?
Yep, just replace the keyword IP with IPv6. Okay, the output looks a little different. You know, it's not organized the same way. But what you see here, you should be able to scroll up, and you'll see your gig 00. And your gig 00 should have, if you're A, it'll look different. It should say FE80:1 and 2001:1 for gig 00 if you're A. Okay? If it doesn't, raise your hand and I'll pop over and make sure you got it going on. And then down below your serial 020, same link local address, FE80:1 if you're A, :2 if you're B, 2002:1 if you're A, :100 if you're B, and they ought to both be up and up. Okay, that's just a display on our side. If we want to test layer 3 connectivity, we can use the packet internet groper or ping command. P-I-N-G, packet internet groper. So give me a do, ping, and ping your buddy's serial side at 200.5.5. I'm going to ping Dion on router A. So I'm doing a ping 200.5.5.1. If you're router A, you go ahead and ping 200.5.5.100. Okay, and exclamations are good things. What's a sign of a problem? Dots, periods. Anybody get a bunch of dots back? No, you're all good? We're batting 1,000 here. Okay, then how do I test IPv6 connectivity? Well, let's go ahead and do that. I'm going to say do, ping, and I'm going to ping my buddy's IPv6 address at 2002:1 if I'm pinging A, or 2002:100 if you're trying to ping B. You got to get exclamations back on that too. Okay. Now, what I'd like you to do is to test connectivity. We just tested connectivity between the two routers. But what I'd like you to now do, if I'm router B, I'm going to try and make an attempt to hit router A's LAN side. I want to hit their local area network. And if you're router A, go ahead and hit router B's LAN side at 10.1.0.1. If you're router B, go ahead and hit 192.168.1.1. So give me a do, ping, and I'm going to ping router A's LAN side at 192.168.1.1. If you're router A, you can try to hit router B at 10.1.0.1. And here's where we're getting a sign of no worky, okay? Things not working. Austin?
For both my pinging pinging the router B and switch B, I have dots.
Okay.
No valid router for destination router.
Okay, and your router A, and Stephen, your router B? Okay, perfect. And you got that from your command prompt? You were able to ping his serial side?
Yes.
Okay, and then when it didn't work for IP version 6?
Right.
Okay, and then so it should have worked for IP version 6. When you tried to hit his LAN side, that should not work. So that's okay. So this one should have worked though. So you see your address is on your interface is up and up. What's your display? Up and up.
I did get.
Duplicate address. Oh, you put in a FE80:2 on your serial side? I might have. You did. Okay, so that duplicate address is messing things up. So
Oh, I should have put in FE80.
:1.
Okay. Whoops.
No worries.
Minutes.
Okay, now give yourself a do ping and ping out.
2002.
May take a second. Okay. I just turned it down, and I'm turning it back up again to see if that corrects the issue. Yeah, there we go. Sometimes you got to shut the interface down and bring it up again if you've had an error that just keeps hanging on. Anybody? Anybody else? All right. Okay. Okay. And why did this fail? Not being able to reach the other person's local area network? Well, because when you set up the interfaces on your router, they will, when they're working, they are called local networks. Your router knows about these networks and can route packets to them. But any network that is not connected to the router, it doesn't know about yet. So the second piece of setting up a router after you've got your interfaces done, you've got to build your routing table, okay? And to be able to route packets to your buddy's local area network, because their network, their LAN is not attached to you, if you're router A, the 10.1 network is not attached to you. So you've got to somehow learn about it, all right? So to do that, we've got to put a route in your routing table. This is called a remote network, something that's not attached to you. And there's two ways you can do that. You can manually program in the routes, or you can run a routing protocol and let the routers talk to one another and build that routing table dynamically. Okay, so let's quick hit some of these slides that we've done here. So we did the configuration of our interfaces. Okay, and we viewed it. The next thing we're going to hit is our routing table. So I'm going to hold on the show IP route command here. We'll get to that. That's going to display your routing table. So maybe let's just do that quick on your router. Give me a do show IP route. Do show IP route. Do show IP route. And what you're seeing, excuse me, I'm router B. So on the left-hand side, it tells you how the router learned about the network. Okay, and C means it's directly connected. So it's an interface on my router. The L is the local entry in the routing table. And for every directly connected network, you have an interface. That's the interface address. That is the interface connecting to that network. So you have a corresponding L entry for each directly connected network. As soon as you bring up an interface, the associated network pops into the routing table, and you can route packets to anything that starts with a 10.1. It can find those. Same with the 200.5.5 network. That's in there now. And my router knows, hey, if you want to get to the 200.5.5 network, well, send the packets out your serial 020 interface. If you want to get to the 10.1 network, this is router B, you go out your gig 00. If you're router A, you're not seeing this. You're seeing a 192.168.1.0. And you send packets to your gig 00. So router B doesn't know about the 192.168 network. So it can't route packets to it. Okay, not until we get an entry into that routing table. If you want to see the IPv6 routing table, you'd replace IP with IPv6, and it would display that table. I'm going to hold on that until we start doing some commands here. Another helpful command is just the show interface command. And if you want to just, it'll show you all the interfaces unless you, I'm going to say do show interface serial 02/2/0. Do show interface serial 020. Okay, this will show you the specifics on just that one interface. If you say show interface, it'll do all your interfaces. But the nice thing about this command, show command, it lets you know the status, layer 1, layer 2 status. Then it gives you, it displays the description there, gives you the IPv4 addressing here. Okay, and if you wanted to see the IPv6 stuff, you could say do show IPv6 interface serial 020. Tells you the layer 2 encapsulation format being used, and then here's some of the helpful information down below. You get a 5-minute summary of input-output. So it's letting you know, hey, here's how many bytes I've received, how many packets I've received on this interface. If I start seeing a lot of errors, like runts, if I get a lot of runts, I get a lot of collisions. If you see a lot of collisions on here, that would be a sign that you have a shared media segment. Remember where we have collided frames and they have to be retransmitted? We usually see that on Ethernet networks. If you have a lot of interface resets, you know, I did a few shutdowns and brought some things up. You might see a lot of, if you have a bad connection to your modem, that may throw a lot of interface resets. If you have a cable that's poorly terminated or is kind of just jiggling loose a little bit, you may get a lot of interface resets. If you see a lot of CRCs, do you remember what the CRC is? Or the frame checksum? What does that do? What does that detect when we're talking about physical layer stuff? Errors in transmission, corrupted frames, okay, where I ran my cabling over some other power cabling, and there's EMI, electromagnetic interference, going on, and it's distorting the signal enough to where it's the ones and zeros are being corrupted. You know, the signal's being corrupted, not being interpreted right. Could be somebody threw their space heater over the cords. Okay, could be you know, all that kind of stuff. So there's lighting and all sorts of other things can affect the signal as it's going through those. Could be attenuation. Cables run too long. Okay, so there's a good command to know. Again, you can see the IPv6 related addressing and information if you do a show IPv6 interface and the interface. And it's important to configure your gateway, your default gateway. And that's just what we did, okay? So who's the gateway? It's a router. You know, your router is the gateway for your LAN to get to other networks. And the computers attached to the LAN need to be programmed with the gateway's IP address. So that is needed. So let's go ahead and set up our host addressing on our computers. So if you would, go ahead and get down on your taskbar. You should see the little globe down there. Right-click on it and say Open Network and Internet Settings. Go to your Ethernet adapter. Change adapter options. And open up your Ethernet adapter properties. Okay? And go to the Properties button. We're going to open up our Ethernet adapter properties. We can set both the IP version 4 stuff and the IPv6 stuff. So go ahead, open up your Internet Protocol version 4 property sheet and tell it, instead of obtaining it automatically, click the radio button that says use the following address. And if your computer B, let me bring up the little network here. If your computer B, set yourself up as a 10.1.0.10 with a 16-bit mask. If your computer A, just change, instead of being 192.168.1.1, give yourself a different number at the end. Use 192.168.1.10. Okay? Okay, your computer B, right? So you're going to, yeah, okay, get into the Ethernet properties. Okay, and so I'm setting I'm computer B, so I'm going to set up a 10.1.0.10 at the end here. And if you're A, give yourself 192.168.1.10. If you're B, you're using 255.255.0.0. If you're A, put in 255.255.255.0. Put another 255. Okay, if you're B, your gateway is the address of your Ethernet port of your router. So that'll be 10.1.0.1. If you're A, make sure you put in 192.168.1.1 if you're A. All right, once you've got those three settings in place, if you're A, it should be 192.168.1.10, 255.255.255.0, and 192.168.1.1 for the gateway. And if you're B, it's everything that's on the board there. Go ahead and say OK. And then scroll down in the Ethernet properties and find the Internet Protocol version 6. DNS server doesn't matter. Yeah, we don't have name resolution services. Go ahead and say use the following IPv6 address. Go ahead, if you're B, put in 2003:10. If you're A, put in 2001:10. Hit the tab key, you'll get a 64-bit prefix, and your gateway is typically put in as the link local address of your router. Now, so it'll take either one. Let's go ahead and put in, you can put in either the global unicast address of 2003:1 or 2001:1, but the other address that is permissible for the gateway address would be the FE80:1 if you're A, FE80:2 if you're router B. Those would be permissible as well. Go ahead and say OK. And in your packet tracer assignment, packet tracer, if I remember right, they wanted you to use the link local one. Okay, but just remember, your gateway can be your router's global unicast address or the link local address. Either one is permissible. They may tell you in packet tracer to use one or the other. And if one doesn't work, try the other one, okay, and the scoring. When the grading goes, when you do the check results. Okay, go ahead and OK that, close it, okay? And then you can close your Ethernet properties. Now you should be able to bring up a prompt on your computer So I'm going to hit the start button and type in CMD. This is a computer prompt from your command line on your computer, not your router. And you should be able to ping your router, okay? But you won't be able to ping your buddy's router. So I can hopefully ping 10.1.0.1, my gateway. But if I try to ping my buddy's router, it's not going to work. And that's because we haven't set up routing yet. Okay, so if I try to ping my buddy at 200.5.5.1, it's not going to get there. Okay? That's because the routing hasn't been configured yet. Okay, so what I'm going to show you to do is to set up what's called the default route on your router and make the routing work. Okay, so here's what a default route means. If my router gets a packet going to a network that's not in its routing table, it's going to forward it out whatever interface I tell it to send it out. Normally at home, like your home router, you know, what network do you use in the inside home network? So you got AT&T or Comcast, but then on your inside IP addresses, your Xbox, your phone, your laptop, what addressing do they normally get? 192.168.0 or 192.168.1. That's what all the little broadband routers are set up to use. Okay, so your router is going to look and it's going to say, oh, if I'm not getting something to one of those addresses, local addresses, 192.168, you know, something, whatever your router's programmed with. Your router is going to be configured with a default route that points to the service provider, your service provider, AT&T or Comcast, and says, hey, I get a packet that's not going locally within my own network, I'll send it to Comcast, or I'll send it to AT&T and let them route it through the internet. Does that make sense? Okay, it keeps your routing table small because you only have to know about the one network's real close to you. If you just have an internet connection and you don't have a lot of internal networks, you can get by with just configuring what's called a default route. So if you would, go ahead and type in, get me back in. I got timed out. So I'm doing a class and a Cisco for my passwords. I'm doing a configure terminal to get to global configuration mode. We're going to enter in a default route. It's using the IP route command. And you're going to put in a default route that points to a network of all zeros. So you're going to say IP route 0.0.0.0, that's 4 zeros, space, with a mask of 0.0.0.0. And you're going to tell the router, if you get packets going to any network that's not already in your table, what interface do you want to send them out? Well, in our case, we don't have a service provider, but we do want to send the packets to our buddy. So we're going to let it know to use the serial 0/2/0 interface. Okay, so the command is IP route 0.0.0.0 space 0.0.0.0 space serial 0/2/0. Okay. Reissue the command, but changing IP to IPv6 and say route, IPv6, route. A network of all zeros in IP version 6 can be represented by 128 zeros, or just double colon is a shorthand for that. A network prefix of 0 can be represented as a bunch of zeros or simply a /0. Tell it the exit interface to pass those packets out. We're going to use the same interface pointing to our buddy's network. And there is one extra thing for IP version 6 that you have to do. You have to say IPv6 unicast-routing. And this tells the router to route those IPv6 packets. The command for IP version 4 is simply IP routing, and that is on by default. Otherwise, your router won't route packets from one interface to another. It's on by default for IPv4, but for IPv6, you got to issue this command. And now, where I was not able to ping my buddy's router at 200.551, I now can. I'm getting a response from Dion's router. And if I look at my router's routing table, I'm going to say do show IP route. You see how we've manually entered in a route, default route, so that if I get a packet that's not going to one of these two networks that are directly connected to me, I'm going to send them out my serial 020 interface. This S stands for static or manual entry, and the asterisk means that it's the candidate default, the gateway of last resort. It's your default route. Every router connected to the internet needs a default route programmed, or they would have over 500,000 entries in their routing table. Okay, because there's a lot of networks out on the internet, IP networks out there, and if you wanted to be able to get to all the public networks out on the internet, I think IP version 4 has over 550,000 IPv4 networks out there. Okay, you'd have a big routing table. Okay, everybody all right with that? And if you wanted to test IPv6 connectivity, you could say from your computer command prompt, I'm pinging 2000, I'm going to ping Dion's gigabit Ethernet side at 2001:1. Or you could ping, if you're A, you'd ping B at 2003:1. Now, if you try to ping your buddy's computer, it may fail because their Windows firewall is on and we don't have an exception program to respond to pings. The software firewall might be on their operating system and not respond to pings. Okay? All right. Otherwise, you'd be able to get to your buddy's computer even. Okay. So if you do not put in the correct gateway for your computers, you'll be locked out from getting to other networks, or the internet. So if a computer has the wrong gateway address or it doesn't have a gateway programmed in its IP settings, you won't be able to get to the internet. Now, remember on a switch, on a Cisco switch, we can say interface VLAN 1, give it an address and a mask. And if we want to be able to remotely administer the switch from another network, you will need to tell your switch who the gateway is, what's the address of the router. And on a switch, you would say IP default-gateway and the address of the router on that network. So you would put in 192.168.1.1 if you're on network A, or if you're network B, it'd be 10.1.0.1. Okay, so that's module 10.